can assist you or tutor you more. If you have more questions, just email me. Alright, question 75 here, the 25th question of the second set of chapter 9. It's a composite centroid problem. So for these ones, especially, if they're composite shapes, usually I don't think your professor would put them on the exam because, they're simply just like counting the middle part and then like times them together. But I think it's important to know the formula, just in case, if it's a chapter review, quiz, or something, he might put on there. But usually these are the one that don't make it on the exam. Usually are the one that requires using calculus and stuff like that. But yeah, we're still using the sum of the x wiggle times dv or dm, or the area, doesn't really matter, and then dv. In this case is the volume, right? And it's homogeneous, so the volume will do the work. And this works for y and z as well, right? These and works for y and z. All right, so let's just get started. You can divide the shape whichever the way you want, but this is how I did, right? This is the first shape over here, and this is the second long block behind the back, right? From this part to this part, and then this third block over here is this one at the front, and this is block 3. So let's start finding centroids. Excuse me, for each block. So for block 1 over here, right? In the x direction, it's going this way. So for triangles, it's 1/3 from the height. So it's 150 times 1 over 3. That's 50. But remember, there is, it's the distance from here to the, to the origin, I'll say, for the x, right? So since this is like 50, but it's not like at the origin, you have to go all the way back to touch the y-axis, right? Or like when x equals to 0. So from x equals to 0 to this point over here, that is not 50. That is, this area over here, this length over here, plus 50. So 150 plus 50, that's 200. So we write 200 over here. For y, write it down in the middle. So that's 50. 100 divided by 2, 50. And we're going to use millimeters. The number is going to get pretty huge. If you want to translate into meters or something, it's up to you. But this is the way I'm going to go to for triangles. Z direction as well, right? 1/3. So from the base, that is 150 times 1 over 3. That is 50. Right? And then use the volume. 150 times 150 divided by 2 times 100 gives you the volume. That should be 1125000. Okay, these numbers are too huge. I'm just gonna read off each digits. So 200 times this, for this shape right here, right? It's 2, 2, 5, 1, 2, 3, 1, 2, 3. Okay, so 225 million. And for y is 2625. 1, 2, 3, 4. Okay, and for z is 5, 6, 2, 5, 0, 0, 0, 0. And this number, we obtained it from x bar times volume gives you this, right? Y bar times volume gives you this. Z bar times the volume gives you this. And let's look at the second shape, right? From the x-axis, we can just write down in the middle, right? 150. Divided by 2, that is 75, right? And then the y as well, right? Whoa, sorry. The y is 100 plus 250 plus 200. I wrote it down here, which is 550, right? Divided by 2, it should gives you 275. And for z, 150 divided by 2, that is 75, right? The volume is 550 times 150 and times 150. So that should gives you 1, 2, 3, 75, 1, 2, 3. Okay, 3 zeros. Sorry, that's what I meant. And yeah, just times x bar times the volume of this second shape. That should gives you 928,125,000. Okay, and for y is 3,4,0,3,125,000, and for z is 928,125,000. Okay, and for second shape over here, we can so the x is 75, but the distance from x to when x equals to 0, that is 75 plus 150, that is 275, right? Sorry, 225, my bad. It is very late, it is almost 2 o'clock, so I'm a little sleepy. Anyway, sorry, y bar is 100, so plus, it has to be the distance to when y equals to 0, so 100 plus 250 plus 100, that should gives you 450, yes indeed. And for y is half of the distance, which is 75, right? The volume, that would be 150 times 150 times 150 times 200. That should be 4 million. How do you say this number? Wait, let me give it a try. 1, 2, 3. 1, 2, 3. 4 million. Right? There's a comma over here. 4 million 5,000. No, I can't even. Wow. Okay. Really? No. It's here and here. 4,500,000. Whew. It is really late. Okay. And for 225 times the volume gives you 40. No. 10125 1 2 3 4 5, and YV, that's 2025 1 2 3 4 5 6, and 3375 1 2 3 1 2. Okay, and then we have to sum all of these together, right, as we did over here. So sum of the volumes. It's even more fun. This is a huge number. This is 18 million. 1 2 3 1 2 3. 18 million for x. The sum of the x times volume, that should be 2165625. 3 zeros, and this for y is 5484375 and for zy is 1321875 Whew. Okay, and now it's just plug everything into a calculator. Well, hopefully you've been using a calculator along the way, or you can just copy down whatever I just said, because this is really a simple question. You don't have to use your brain that much, to be honest. I don't think they require much of a math. But yeah, so this is the sum, right? So this is the sum. So this number over here is the sum of the x bar times dv. So now we just have to divide by the dv, which we calculate over here, which is 18 million. That should give you 120.3125. Round to 3 digits, that would be 120 millimeters. 1 millimeters. And now this number divided by 1800, that should give you 304.6875. Round up to, 3 digits, that would be 305 millimeters. And for z is 73.4375, and round out the 3 digits, that would be 73.4 millimeters. And this is it, right? This is the answer for this question. Again, yeah, try not to spend too much time on these questions. I really don't think he's gonna, professor's gonna put an exam question on this, right? It'd just be a free point. But if he's nice, usually for static exams, you have like 5 to 6 questions, 7 questions, depends on your professor. Usually it's not that long because they're all the free body diagram. It takes time, so he will probably not waste a spot on putting one of the composite shapes. It usually be one on trusses, one on centroid, one on chapter 10, right, in moment and inertia, and then one from chapter 5, and then chapter 3 probably, and then maybe a wedge problem. I don't know, but yeah. But anyway, if you wanted to want to do these things, hopefully this video was helpful, and good luck in your studies. I'll see you in my future videos. Bye. If you have more questions, specific questions you would like me to do, please comment in the comment section down below.